Hello, welcome to your first video for trigonometry, and we're going to start by reviewing some geometry where we kind of covered first touch on trigonometry with SOHCAHTOA. Remember that sine is going to be your opposite over your hypotenuse, the O and the H. Cosine is adjacent over hypotenuse, the A and the H, and tangent is opposite over adjacent, the O and the A. Now we're going to look at a couple new trig functions. We have cosecant, and cosecant is the reciprocal of sine. So instead of opposite over hypotenuse, it's hypotenuse over the opposite side. And again, that is going to be cosecant. Secant is the reciprocal of cosine. So instead of adjacent over hypotenuse, it's hypotenuse over adjacent, and that is your secant. And last is cotangent, reciprocal of tangent. So instead of opposite over adjacent, it's adjacent over opposite, and again that is cotangent. Another way to look at this cosecant, instead of flipping them, we know that it's the reciprocal, so it's also 1 over sine of theta. These two things mean the exact same thing. So secant is not the inverse, but the reciprocal. So that's 1 over cosine of theta. And this is 1 over tangent of theta. Again, these two things mean the same thing, just a different way of writing it. Alright, so let's look at our triangle. We have our angle ABC. We have sides 3, 4, 5. I want the sine of angle A. If I want the sine of angle A, I'm looking at the opposite over hypotenuse, so opposite of A is 4, hypotenuse is 5. I want the cosine of A. Cosine is adjacent over hypotenuse. If this is A, this is my adjacent side, and my hypotenuse is 5. Next, we want tangent of B. If this is B, tangent is opposite over adjacent, so opposite of B is 3. Adjacent is 4, so this is 3 over 4. Now we have some new ones, cosecant, and we want cosecant of B. When we look at cosecant, we want hypotenuse over the opposite side. So if this is B, the hypotenuse of that triangle is 5, and the opposite side, opposite B, is 3, so that's 5/3. Secant is hypotenuse over adjacent, and we're looking at secant of A. So here's my angle A. My hypotenuse is 5. My adjacent is 3. And our last one is cotangent of B. So again, we start with B. Cotangent is adjacent over opposite. So if here's B, my adjacent side is 4, my opposite side is 3. So that's 4/3. Alright, so we're going to do a real quick special rights triangle review. You've done this several times. You did this in Algebra 1, you did it in geometry, you did it twice in geometry, and now we're going to review it again. With our special rights triangle, 1 is 45, 45, 90. The legs of your triangle are congruent with S. Your hypotenuse is whatever those legs are, √2. With your 30, 60, 90, it's a little bit more complicated. You've had to find the 30-degree angle. There's our degree marks. Across from 30 is going to be S. Across from 60 is S√3. And across from 90 is 2S. Now when you have special rights, the easiest thing is if you are given S. And if you're given S, you can just plug it into the other pattern pieces. But probably life is not going to be that easy. So we look at our first one. We've got a 30, 90. That means that this has to be 60. So across from 30 is S, across from 60 is S√3, across from 90 is 2S. So, like I said, life's not that easy. We weren't given our S, but instead we were given that S√3 is equal to 9. My guess is a lot of you can do this in your head by now, hopefully, maybe. If not, don't worry, just set up your equation. If my pattern piece is S√3, and I'm told that S√3 is equal to 9, if I can't do this in my head, I can go ahead and just set up an equation. S√3 is equal to 9. We divide by √3. But we can't have radicals on the bottom, so then we have to rationalize by multiplying top and bottom by the square root of 3. That gives me 9 root 3 over 3. Then 9 over 3 reduces down to 3 root 3. So my s is equal to 3 root 3. This side is representing my s, so this side is 3 root 3. And then my hypotenuse is 2 times s. Well, 3 root 3 is s. I multiply that by 2 to get that side is 6 root 3. So again, if you can't do it in your head, just set up that equation and solve. So we go down, we've got another 30, 60, 90, 30, 90, 60. So we've got s root 3, 2s. Probably think we should have started with this one because this one is nice. We are given that s is 3. When we're given s, life is so much easier, we just plug it in. This is s root 3, so this becomes 3 root 3. This is 2 times s, 2 times 3 gives us 6. Not too bad. Alright, let's move on. We don't have 45, 45 given to us, but we have a 90-degree angle. We're given an isosceles triangle, which means that these base angles are congruent. We know that all 3 angles add up to 180. I take away 90. That leaves me with 90 degrees left, split evenly. This is 45, 45, 90. So s root 2. Again, at this point, we have s root 2 is equal to 10. I wasn't given s, but I can easily find it. Probably can do it in your head, but if you can't, set up the equation. S root 2 is equal to 10. That's the pattern piece and what the pattern piece is equal to. We divide by root 2, we rationalize, and we get 10 root 2 over 2. 10 over 2 reduces down to 5 root 2. And that's going to be my, again, s. Well, both of my sides are s, so that's 5 root 2 and 5 root 2. And our last special rights review question. Here are my legs, so s root 2. I want you to go ahead and try this one on your own. Probably can't do this one in your head, so go ahead and set up your equation and solve for your s. Press pause. Alright, as we set this up, we were given our s root 2 side. We set s root 2 equal to square root of 13. We divide by root 2 so that we can get s by itself. Then we rationalize. 13 and 2 are both inside, so they stay inside at square root of 26 over 2. Those don't reduce because 26 is inside, 2 is outside, and 26 cannot be broken down any further. So each of our s's are the square root of 26 over 2. Alright, the next thing that we are going to review is how to do those trig functions in your calculator. Always make sure that your calculator is in degree mode. So go ahead and check now. Press pause if you don't have your calculator out. Okay, so to check the degree, we hit the mode button, and we want to make sure that that degree is highlighted. If not, just put your cursor over it and press enter. When we have trig functions, sine, cosine, cotangent, secant, cosecant, all of those, any of those, tangent, it's always whatever your trig function is of the angle set equal to the ratio of the sides. So when I look at my first problem here, I have sine of x is equal to 12 over 13. This is telling me that I am solving for an angle. When I am solving for an angle, we have to use inverse trig. And because our trig function is sine, we need to use inverse sine. So we want inverse sine of 12 over 13. So we go back to our home screen. We have sine. Right above sine, you see the inverse sine, so we hit second sine. 12 divided by 13. We hit enter, and that is going to give us our degree mode. Now in geometry, you always round it to the nearest degree. We're going to learn something a little bit new. We're going to go into degrees and minutes. And you're lucky in the fact that your calculator will do this for you. So we are going to hit second apps, and second apps you see in blue says angle. And we want number 4, DMS. That stands for degrees, minutes, and seconds. We're going to turn our last angle, we want that stored, so see how it says ANS? We want the answer, the previous answer of 67 point blah 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 blah, to be turned into degrees, minutes, seconds. We hit enter. We have our angle is going to be 67 degrees. Now we're not going to go to seconds, we're only going to go to minutes. It's not necessarily going to be 22 minutes. We have to look at our seconds to see, do we round up or does it stay the same? Most of you probably thinking to yourself, okay, it's going to stay the same because 48. You would think 5 and up, you round up. But we have degrees, minutes, seconds. Think about minutes and seconds from a clock. There are 60 minutes in every hour. There are 60 seconds in every minute. That same idea is going to be true here. There are 60 seconds for every minute, 60 minutes for every degree. So 48 is actually more than halfway because 30 seconds would be halfway. So this is actually going to round up to 23 minutes. Okay, and then our next one, we've got cosine of 47 is equal to x over 10. Here we are solving for a side. And when we're solving for a side, we just use our normal trig functions. If x is on top, we multiply. So x is equal to 10 times the cosine of 47. What you want to be careful about here is that you're only taking the cosine of 47 degrees. So always put that 10 first, or whatever you're multiplying by. 10 times the cosine of 47. You can close it out since there's nothing coming after, it doesn't matter, but if you had multiplied by 10 after, you want to make sure that you close out so that only 47 is inside those parentheses. And that gives us that our side length is going to be about 6.82, rounding to the nearest hundredth. And our last one, we've got tangent of 33 is equal to 7 over y. We're solving for a side again, because it's in that ratio side, but this time our side is on the bottom, which means we're going to divide. So y is equal to 7 divided by the tangent of 33. And we go 7 divided by tangent 33. We get that our y is going to be about 10.78 when rounded to the nearest hundredths position. Okay, so again, that was a review. When we turn over to the back side, we've got some new stuff here. Now we're going to talk about solving for a triangle. If I'm solving for a triangle, I'm solving for all given pieces. According to this triangle, we have an angle A, an angle B, an angle C, a side A. Notice that side A is opposite of angle A. Side C is opposite of angle C, and side B is opposite of angle B. So when you are solving for a triangle, you have 6 pieces: side A, side B, side C, angle A, angle B, and our angle C. All 6 pieces need to be solved for when you are solving for a whole triangle. And when you are solving for a whole triangle, you always want to use exact or given values when possible. Sometimes it's not possible, but use exact or given values as much as possible. When you round, you lose a little bit of the integrity of the number. So if you are using a rounded number to round, to round, to round, by the end your number is going to be pretty far off. So let's go ahead and look at our first triangle. We have angle A, which means we are missing side A. We are given side B. We are given side C. And we have one 90-degree angle. So if we write out all of our information, what we're missing is side A, angle A, and angle B. When I look at side A, don't overcomplicate things. Look for the easiest route. Just looking for the easy way out isn't always necessarily a bad thing. I really don't have to use trig here. I have a right angle, I have a hypotenuse, I have one side. So to find A, all I have to do is Pythagorean theorem. A squared plus 3 squared is equal to 7 squared. Side squared plus side squared is equal to hypotenuse squared. So we get our side squared is equal to 40. We, as much as possible, want to give an exact answer. So you would have to break this down with a factor tree. We got a pair of 2's with 10 left over. So our side A is going to be equal to 2 square root 10. Be comfortable with both exact answers and rounded answers. If I want my rounded answer, I just go to my calculator, 2 square root 10, enter, and we get that it's about 6.32. Again, you want to be comfortable with both of them. So the next thing we need to solve for that we don't have is angle A. So if I'm looking for angle A, I'm going to use my given side. So I was given 3 and 7. In relationship to angle A, 3 is adjacent, 7 is hypotenuse, which means we have cosine of angle A is equal to the adjacent over the hypotenuse. We have to use our inverse trig because we are solving for an angle. So we go second cosine, 3 divided by 7. We hit enter. But remember, we don't want to the nearest whole degree, so we have to turn that into degrees minutes second. Second apps. Number 4, enter. We see that angle A is going to be equal to 64 degrees. 23 is less than 30, which is halfway, so it's going to stay as 37 minutes. And then our last one there, we need angle B. Again, we're going to use the 3 and the 7. 3 is opposite, 7 is hypotenuse, which means we have sine of angle B is equal to 3 over 7. I want you to press pause and do this on your own. It is very, very important that you are touching these buttons on your calculator so that you have that muscle memory when it comes to quiz time. Alright, I did make you do this the long way, and hopefully you ended up with 25 degrees in 23 minutes. For future reference, you can always do, we know that all 3 angles in a triangle add up to 180. So 180 minus 90 minus the 64 degrees in 37 minutes. Where these pieces are located, if I wanted to do that, 180 minus 90 minus 64, we're going to go to the same place we go to DMS. Second apps, 1 for degrees, 37 second apps, we see 2 for minutes. And then we would have to go ahead and turn that back into our DMS. Okay, we have one more, solving the triangle. When we look at this one, we have angle A, angle C. What I'm missing right off the bat, I see, is angle B. Again, don't make it harder than it is. We know that all 3 angles add up to 180. So 180 minus 90 minus 35, we get right off the bat that angle B is equal to 55 degrees with not much work. But next thing we need, we are missing side A and we are missing side B. Remember, side A is opposite of angle A. So I'm going to use what I'm given. I'm given 35 degrees and I'm given a side of 10. A is opposite, 10 is hypotenuse, so this would be sine of 35 degrees is equal to A over 10. I'm missing my side length, and A is on top, so it's 10 times the sine of 35, which means A is going to be about 5.74. And then our last missing piece is B. We given 35, given 10. B is adjacent, and we have hypotenuse. Adjacent and hypotenuse is going to be cosine. So cosine of 35 is equal to B over 10. Again, we're going to multiply 10 times cosine of 35, and we get that b is about 8.19. It is important that you have the correct labels, that the sides opposite the angles have that same name. Okay, our very last one, I know this is a long video, welcome to trigonometry, is an application. You're going to have lots and lots of application questions on quizzes and tests. So word problems, we are going to round answers to the nearest tenth. A tree cast a shadow on the ground that is 50 feet long. So we have our tree. I know you guys are jealous of my artistic abilities. And that tree is going to cast a shadow on the ground. So we are looking at this distance, because it's on the ground, of 50 feet long. The angle of elevation from the end of the shadow to the top of the tree is 53 degrees. We know that angle of elevation is going up from the ground to the top of the tree. That would be our 53 degrees. How tall is the tree? So we have opposite and adjacent. Opposite and adjacent is tangent. We always want the trig function of our angle, our opposite side over our adjacent side, which means that we are going to multiply. When we multiply those pieces, we get that x is going to be about 66.4 feet. Anytime we have word problems, you must label those answers. Now that's the way I would have done it. There is a second way we could have approached this. We know that this is 90, that's 53, which means this is 37 degrees. If we do it that way, we have the adjacent side and the opposite. So we still have tangent, but this time tangent of 37 is 50 over x. Since our unknown is on the bottom, we divide, and we get x is equal to 50 divided by tangent of 37. But we still get the exact same answer of 66.4 feet. So there are multiple setups for a lot of these problems depending on which angle you use and how you look at it. Alright, now we are finally done with our first video. Sorry that it was so long.